Hello. All right. So, I think I said at some point I was kind of done with the OCI live streams, but I needed something easier to wrap up this week. I initially meant to do a live stream on like improving some of the Incus UI, fixing some bugs there, but I didn't really feel like doing JavaScript stuff today, so I ended up going with OCI again because there are a few reports that I want to look at and just kind of tweak things a bit to make things work better. Um, I also see that Jared actually had an OCI related question slash issue with trying to export an OCI image and getting the wrong hash. Um, yeah, it's not something I tested. It's something I can definitely see happening because we've been cheating on the hashes. But we'll see if there's a good way to handle that. All right. So current state of the. I'm just gonna go to the code here and update on what's currently been merged because I pushed a lot of kind of cluster related changes yesterday. So just want to make sure we're all good. Okay. All right. Cool. So building that and I'm gonna go and just put it in place on my system. So I'm running the latest and greatest effectively for any of this. Can just look at the image issue. Like it might be a bit of a tricky one to fix, but we can at least look at what that looks like. So just create a random folder. Already exists. Okay, cool. Look at the image list and then do export on one of the OCI images. Just looking for a small one. Do I have a hello world? That would be convenient. I don't. Okay, fine. Let's do Nginx should be small. So if I do that, yeah, there we go. Image fingerprint does not match. Expected something different. So that's effectively, so what we've done is we line up the fingerprint that's recorded with the fingerprint from the initial registry, but they don't hash images the same way we do. So we're hitting a bit of an issue when returning them. I'm gonna see if we can easily put some kind of bypass for OCI images specifically. I don't recall if we've got a property we could check for that. Yeah, type OCI. Okay, so that might be a bit weird, but we might be able to do something. Let's see. Image fingerprint doesn't. I mean, ideally we would have a way to actually recheck the image. Yeah, so that's on the client side. That's the issue. Okay. So it looks like what's going on is it hits the server, it asks for the image files, they're being retrieved and hashed, and the resulting hash does not match the expected fingerprint. So, I mean, ideally you would want a way to actually hash the content so that it ends up lining up. I just don't know exactly how the OCI hash, the Docker registry type hash we're getting is computed. Okay, let's see. So it's failing here, and there must be a similar one for a full image. Yeah. Okay. So we know we're not gonna hit this case. We're gonna hit the other one. It does show the error. I wonder if it's. I mean, it's returning an error. But the question is, does it still give you the file? No, because the file's gonna end up in being like a temporary file, effectively. Like one way would be to actually add an additional header that we could get with the correct fingerprint. The point is that I don't think we know the fingerprint on the server side. Do we know, well, how much do we know about the image at that stage? So we know the fingerprint, okay, but that's about it. Then we get URI. What's being passed to that? It's probably the full fetch URI. Yeah, it's then loading, grabbing the content type. Okay. So what's calling in custom node image? Because that's an internal function. Okay, so it's called in two places from here, which is probably a get private image file, and we probably use get private image file even for public, which makes sense. The URI with the export here, and we, at that point we know the fingerprint, the secret, and an image file request, which is probably just the two, the kind of the two files we need to write for the two different things. Okay, so then that fetches the image. Okay. Yeah, it's obviously gonna be a bit of an issue on that one. What's a like an easy bypass would be to expose a header that effectively tells it to bypass the fingerprint check because we're expecting an OCI format. That probably works. That's easy enough to put in place. I don't love it because I would like to still hash something, but at the same time, we're downloading over HTTPS, so it's not like well, like in the simple streams case, we absolutely need to do this because of our simple streams we download over HTTP with a fallback to HTTPS. So over there, someone could literally modify the image as it's being sent over the wire and would have big problems. In this case, that's not really true. Like there's no really good way to intercept anything, so we could bypass it for OCI images. I'm thinking like it would be kind of neat maybe to be able to hash the data that we're sending to the client. But the problem is when we do that, we only get the hash on the server side at the end of the transfer, so we can't put it in a header, and we don't really have anything but a header that we can use to communicate to the client. So not ideal. Let's just go look at the export route and see if we can't expose a header to tell us this is an OCI format image. So effectively expose Incus as the default format. If we see image type is OCI, then we expose OCI, and then the client can decide what it wants to do with this, which in this case gonna mean skipping the fingerprint check. Okay, I did just do a show on it. It's properties and its type and OCI. Okay. I want image export. So that's the function that takes care of that. Let's just go look at this image export cmd. Okay. And then the image export function itself is here. This should actually get the full image. It does. We've got image info, which means we do have the data we need to then do then set headers effectively. Okay, that's cool. Okay, so it's looking up the files, detecting compression, all that stuff. File name. Okay. So, and then give the file response with the different files. So we need to do, before that, we need to go and mess with headers. So let's do, what do we do that? So that's for, this is the correct node, so we should ignore that. And around here, we should look at set image type header. So I'll just do image type default is Incus, and then if I don't know how that actually works. Let's assume image info properties, and then we want image info properties is not null, just in case. I don't know if it can be null, but let's not take the chance. Type, and if it's OCI. We're not going to support arbitrary values and just want to only support Incus OCI for that. We do that. And then what's the magic for that again? So that's the request. We need to be able to set some headers, and that's going to be slightly problematic, I think. What does a file response take? Does it let me pass headers? That'd be neat. We want, yeah, it does. Headers map. Sweet. Okay, so I got lucky. Otherwise, I would have needed to do a bunch of refactoring to make that possible. All right, so let's just do headers, initialize that to an empty map. And this becomes headers at, what's our usual format? It's x incus something, I think usually x incus. Yeah, there you go. So this would be x incus type. Okay. And do this one, CI. Okay, and then file response. So instead of null, we pass the headers. Okay. Looks like that's building the first time around. Yep, I'm good. And now on the client side, so we had that fingerprint error, image fingerprint, something. There we go. I'm just gonna change the check to that, and then get the actual image type. I'm sure we'll fix that some different ways down the line. Like again, as I said, I don't really love it. I don't see any actual security type concern here because it's all over HTTPS. It's fine, but I still don't love it. I would prefer to have some ways of actually validating that the data we're getting lines up with the registry fingerprint. Like I know that the hashing mechanism is going to be different because they just don't use the same hashing we do, but still would prefer that be handled slightly differently. Okay, so response header. Okay, so we can probably put it here. So the image type is response header get and x incus type. And if it's empty, we just default to incus. Doesn't really matter since we only key off OCI down there, but might as well. Okay. So in theory, if I go and actually rebuild the server side too, so I'm restarting an older version, should probably do that again then. Okay, and then go into A and export things again, see what that does. Okay, that's better. And we do have the hash. So yeah, basically like the files are fine, it contains the right data and it's all good. But the way it's normally handled by Incus for images is that the hash should be metadata plus data and SHA-256. That's how we compute our own hashes, which doesn't actually line up here. That's what's causing the issue. The current approach has been to effectively record it with the wrong hash in the store. So the image store records the hash as it's reported by the registry instead of computing the hash, computing our own hash. That's something that we might change. Like we might go to actually using our own hash so that it lines up with the rest of our logic and then keep the registry hash as a property of the image. The main reason why we need to know that is that's how we refresh images. So in the background, every, I think 6 hours by default, 3 hours maybe, we go and look at all of the images we have cached. We look at what name was used to query them. We query that name again, check what the fingerprint is, and if it is not the same one as the fingerprint we have in our store, then we know the image is out of date, and we start refreshing the image automatically. Now, obviously, if we hash the image a different way, then when we go and talk to the registry, the hash will always differ, which then causes the image to be refreshed every single hour. So that's what we're trying to avoid by this current trick. But we could also effectively keep that as a property. And so when we compare with the registry, we don't compare the image hash itself, we compare that property we have on the image instead. So that might be the way to go. It's going to be a bit more difficult, a bit weirder internally. So I think for now, this trick works fine. And I think it's useful for the client to know whether it's an OCI image or not anyway. So that having the extra header doesn't really hurt. It's the hash validation that we might put back on once we've changed the logic and did a bit on our side. So anyways, let's just commit that stuff. So on the Incus side, expose image type as header. Okay. Skip fingerprint, skip image hash OCI, and this one I'm gonna put a bit more context in. Image the as the native guess images. And check the hash. Should probably fix that typo. Huh? Secure transport, local Unix socket or HTTPS. Needing the extra addition and like all right. Cool. So that should be fine for this one. Just see if there was any issue needed fixing. And then we'll go and look at something else. How do you keep track of these fixes you don't like? Well, mostly in my head. This one we might need to open an issue for. It's not clear yet what the right solution is, and there's a bunch more pieces we kind of have in mind for OCI moving forward. I think I mentioned in the previous live stream, like, trying to handle layers. And the moment we start handling layers, then that logic is gonna need changing. So that's why I'm not too worried about like forgetting this one, for example. Like I could have put a fix me, but it's or a node or something like that in the code, which might increase the chance of seeing it, though we've been pretty terrible at seeing those anyways. I think in this case, it's like, as things stand, that's probably the best way we can do it. I don't know of any way for us to actually regenerate that hash without very deep inspection of the data and talking to the store and everything. And down the line, we'll move to storing the individual layers, which is going to completely change what happens during an export. So right now, you export, you get the two files similar to an Incus image. Once we do switch to downloading individual layers, then when you export the image, it will effectively download a whack ton of files. It's going to download every single layer you need, plus effectively a manifest telling you how to stack them. And then, well, in that scenario, we're going to need different hashes for all of the different layers, and we'll be able to put that. Yeah, I don't love fixmes. The only I use fixmes while I work on some specific piece of code because VI helpfully highlights them for me. But I don't know if how much do we probably do have a bunch of fixmes, but hopefully not too many. Okay, in the test suite we've got a bunch. We've got relatively few in the server, so on the server side, so that's pretty good. And usually, if I see one, I tend to get rid of them because the reality is that often the code changes a bunch and the fix me's don't. And when you look at the fix me again, they rarely are still relevant. So yeah, I'm also not a big fan of having those. Like if something needs proper tracking, an issue tends to work way better because we can actually milestone it. People can have good visibility on that. Um, Otherwise, if it's code that we know is gonna go away because of other work that we need to do, then what's the point? Um, it's kind of the same thing with I've seen in the past, like folks commenting out a bunch of code because this is not needed right now, but we might need it later. It's like this is all in Git, right? We can just get the Git history. We can just like if something shouldn't be there anymore, it should just go away, and we can always put it back later. Type thing. All right, so this is this one fixed. Static analysis, everything's happy, so we're good. I did have mention of, well, there's two things I want to try and run. One might just work because I haven't actually tried it yet. It's just I keep running it in like nested containers and stuff, so I'd like to make sure it works on its own, which would be Keycloak. And the other one that I want to look at is Frigate, which is what I use for cameras. Just need to check if I need to do any kind of cleanup in my project here. Let's get rid of those two. Okay, I'm gonna switch to my demo project instead. Can't even type project name correctly. Okay, this one has a few things running. Let's just wipe all that stuff up. Failed to remove. Okay, sure. Why? Anyways. Not sure what goes going on with that VM. Okay. Anyway, all good. Yeah, so I want to try and run Frigate because we had reports that this doesn't work, and because it's a piece of software I actually do use myself, figured that would be a good one to try and get going. For those not familiar, Frigate is effectively there. Oh, actually, good cat. We can see the cat eating. For the usual "where is the cat" questions. So yeah, it's got all of my cameras on the property here, and it also does. Just switching to having the proper live stream. Hopefully, come on. Okay, doesn't feel like it today. Fine. So yeah, I've got all of my camera feeds running in that thing. It's running on a reasonably beefy server with both an AMD GPU that can do all of the video encoding, decoding, and a USB Coral stick, which is used to do all of the AI inference tracking and stuff. So we should actually be able to do it here. So if I do debug, and then I turn on some of the layers, hoping the cat doesn't go away quickly. Yeah, there we go. So we can see all of the motions and everything. We can see it's 80% sure this is a cat. It sees what's moving and effectively, yeah, lets you trigger events. This is integrated with my Home Assistant, so I can automatically get notifications if someone shows up in the driveway or walks around the house, if something's going on with the chickens in the backyard, etc. So you can see like this is effectively doing live analysis of the video and just giving the extra context. So this is a massive pile of Python plus custom FFmpeg plus a whole bunch of other stuff. And usually you'd run, like effectively the only way that upstream supports running it really is as a Docker container. So that's what I've been doing. I'm running it inside of an Incus container with then having Docker in there and then running that as a container. And I've got a couple of folks I think on the forum who reported that this particular image, so the Frigate image, just does not start under Incus. And that's probably a very simple issue with it running a S6 in its system, but not running it S6 effectively does not let you run it as a secondary process. So if it starts at speed 2, it just fails to start. And we've got a bit of logic already in place to handle that with another image. I'm not sure which one had the issue. I suspect this one just uses a different path and should be very easy to fix up and get going. For Keycloak, I've got zero idea whether it's gonna work or not. It's another kind of complex one, but it's mostly a part of Java, and there's a good chance it would just work. Okay, and the cat is gone. So yeah, that's basically what I use Frigate for. I've got this like bunch of cameras kind of covering everything. So don't see the cat currently on the kitchen one, but anyways, yeah, we can see here we've got the equivalent, but with the chickens instead. Oops, it's waiting for frames. Okay, it's a bit of glitchiness here. That happens sometimes. The RTSP stream is not always super solid. Yeah, definitely glitching on this camera. Come on. Yeah. Anyway, is the other chicken inside? That would be easier to see. Yeah, there we go. This one's working. Doesn't really detect that it's a bird, but yeah, it does sometimes. Anyways, that can feed into a bunch of events and can then quickly analyze. It's not always right, as you can see. This one, it thinks a chicken is a cat, so that's the models like those machine learning type models. They're really hit or miss, and they often miss. Like all of those are false positives of like it thinking there's a bird or something. And like here's the car, that worked fine. Occasionally it does pick up actual things. So that's a bird walking on the grass. That's fine. Yeah, deliveries and stuff. I think there was, what was it? I thought there was some more recent stuff. Anyways, no raccoons last night apparently, so that's good. Where was it? Yeah, this is most definitely not a bird. But it did pick up the movement at least, so there's that, you can see. And going for the fruit trees. This one was also counted as a person when it should definitely have triggered as a bird. It was literally about going right by the camera, as you can see. Anyway, that's Frigate for you. And the question about whether the cameras follow the cat. They don't. Current version of Frigate does not support PTZ cameras correctly, I don't think. So effectively you can have, like, you can put a bunch of masks to have it ignore specific areas of the frame, which I think I've got set up at least on one of the outside cameras because it keeps glitching and that was bugging me. Which one is it? It's this guy probably? Yeah, this one. So on this camera, again, live view is fine, but the still on the motion MPEG is motion JPEG is not working right now. I don't know why. Come on. Why is like live was fine? Oh, yeah. Come on. It's a bit finicky sometimes. Yeah, so anyway, I can't read the mask at the same time. I've got a mask configured here to block this tree because otherwise it counts as a bird during the night for some reason. And if you put a mask in place and your camera supports rotation, so it's like it's a PTZ camera, then when it moves, the mask doesn't stick to the right place and ends up masking a bunch of stuff. So that's a bit of an issue, and I think the next version is supposed to handle that better. But currently, no. Anyway, black shade. Yeah, so that's the actual project on GitHub. You can see last release was February 17th. It's running 0.13.2, and I think they should have the instructions for Docker somewhere in here. Documentation. I'm just looking for the actual Docker command. I don't remember what the image is I'm using. What is installation? That's probably where it's telling you. There we go. That looks like Docker. Okay, so basically this is the path. So ghcr.io. This is not actually Docker Hub. It's another different registry. So we're gonna need to add that because this is the actual path. Remote. And I don't know what the actual URL is to make this one work. Let's see if that works. I'm not convinced, but who knows. It's protocol OCI. Okay, image info and this. The question around will RISC-V images be supported in public official images? So not, yeah, right. RISC-V is on my to-do list of stuff to add. And I'm currently waiting. There's potential funding coming in for that and for some other stuff from kind of indirectly European Union. So maybe it will work out. If I do get, like, it is something I listed as would be covered by that funding. If that gets approved, and I should know in the next few weeks, then I will be buying some RISC-V hardware to put in the build farm so we can start building RISC-V images. If not, then yeah, anyone who wants to contribute to that, that'd be welcome, and we can sort out what's needed there. There's kind of the two different aspects. Like one side is obviously you need to start building images. So that needs like 24/7 reasonably beefy machines that can handle the image building. And the other side will be also likely adding ideally GitHub builders, so GitHub runners, to build some of the packages as well. So we can have for example, like the Zable Incus package repository be available for RISC-V on both Ubuntu and Debian, so people can just pick those up and don't need to manually build things. But the images is kind of the first step, really, and for that, yeah, I'm waiting to see if that gets funded that way. If it does, then that's great. If not, then find a different way to do it, since there's actually a bunch of interest around that. Like back in NextD, we were doing a bunch of other architectures. Like we were doing PowerPC, IBM Z series. Those not very commonly used by people, really. Even ARM 32-bit, I stopped completely publishing images for that for a while. Because I just didn't really have any hardware that was capable of still doing 32-bit. But then that did get sponsored by a customer of mine, so we've effectively got another year of ARM 32-bit images now. And yeah, RISC-V is something that people can pretty easily get their hands on. Not necessarily the most powerful hardware, but you know, there are good boards that you can get and that could run Incus pretty well. The trick on our side tends to be finding good hardware on kind of the builder server side, because ideally for us we want minimum 8 cores, 64 gigs of RAM, NVMe storage, 10 gigabit networking, and a baseboard management controller so you can shut down, reboot, etc. the remote machine. So that's the part that's a bit tricky. Last I checked, I think Alibaba effectively had made some of that kind of hardware, but wasn't commonly available. And most of the dev boards that you could get were only fitting some of those criteria. But at the same time, that's what we commonly use for builders, not necessarily what we actually do need, because not all distros support RISC-V 64. So we can also have something lower spec that takes longer, that might get stuck. It's okay-ish. The main concern being that for us, we publish everything together. So say we add RISC-V 64 to Debian or Ubuntu, we won't be able to publish any new Debian or Ubuntu images unless they also have built successfully on RISC-V 64 and have passed tests. So that's where like one architecture kind of lagging behind or having some issues is going to impact the other architecture. So that's why we're trying to be kind of careful there. But anyways, yeah, I'm hoping to hear back about some of that funding stuff very soon. I got an email, I think, earlier this week that said that, hey, they're ready to start talking and they will reach out to book an appointment soon. So we'll see if there's any money coming for the project that way. If not, then we can start like a forum thread or something to get good recommendation on hardware that would work well, that will work well for this, and try and get something up and running. Okay, so it just worked. That's cool. Image info, we can access the. So we've got some specs. Okay, so it has 8 core, 16 gigs of RAM. Cool. Yeah, we don't need virtualization, so there's a question like whether like about KVM. It's fine for the image building. We can do it. We do it in containers, so that's okay. Virtualization is nice because that lets us do more of the validation testing. So that's one of the issues we've got on ARM, where because the builders are virtualized themselves, they can't run nested VMs because that's not a thing on the hardware I've got. So on ARM, it means we can build images, but we can't actually we can test the container images, but we can't test the VM images. Now, if we had support for nested virtualization on ARM, or if we've got support for KVM on RISC-V, then it means we can not only build VM images, but also test them. Realistically, I think for RISC-V, given what's currently available for most users and the specs on those, I think we would probably stick to just making container images for the first as the first step. And those can then easily be tested, no problem. It's only when we get to VMs where things get a bit trickier. But for VMs, it also means we need to now start figuring out QEMU and firmware and adding support for that in Incus, which we don't currently have for RISC-V. So anyway, we'd focus on containers, I think, initially. And I think that's also what I put in the kind of funding request, being this is for RISC-V 64 containers on the most common distros that already support it. So yeah, but yeah, RISC-V is pretty exciting. It's been pretty amazing to see how quickly it's evolved and kind of the specs it has now. Like I still remember when we were doing the initial port back when I was at Canonical, and the most powerful thing you could get was, I think there's like 1 or 2 cores clocked at maybe 2 gigahertz max. Very small amount of RAM, and especially PCI was a disaster at the time because they didn't have PCI ASICs in there. So the PCI was done through an FPGA connected to the board somehow, which made the board insanely expensive. I think it was like $2,500 or something like that, and not have particularly amazing performance either. So it's been good to see a lot of improvements. It feels like we can probably get now off-the-shelf hardware and make it work. Not ideal, like it's not something I can join just in my home cluster and treat as like a production grade server, but good enough to put somewhere in the lab to build some images on. So anyway, back to Frigate, we can see image info worked, so that's cool. Now let's just try and launch it. I suspect the image is gonna be large-ish, it's 600 megs. Okay, so let's do that. That's gonna take a little while to actually download everything, convert it, import it, launch. Oh, that's good to know. Yeah, so apparently the Q1 2025 there might be some hardware that does KVM support on RISC-V. Like that's the thing I've been hearing about for a while because I am one of the organizers, well, one of the microconf organizers for containers and checkpoint restore at Linux Plumbers. And that's the Linux Plumbers conference that happens every year. It's going to be in Vienna this year in September. And that's also where there's the Linux Kernel Summit and a bunch of different tracks. And one of the track there is RISC-V 64. And there's also tracks for virtualization and a bunch of other things. So there's often been hallway talks of like, okay, when do we actually get silicon that supports KVM? And also for a number of years, the question was, okay, what actually needs to go into the KVM spec, like the virtualization extension spec for RISC-V 64? Because I think at the time Alibaba had already done something for their own cloud, but it wasn't necessarily the way everyone else would have wanted to do VMs, something like that. I remember there being a bunch of kind of discussion for what should virtualization look like as a CPU extension on RISC-V 64. Then implementing that, they usually start by doing a lot of that stuff actually through QEMU, effectively implementing it in software, making sure that everything works well before anyone starts doing the silicon side of things. And then when the silicon actually does exist, then need to do all of the usual support and validation kind of throughout the stack. So in our case, that means getting QEMU that works with it, getting a firmware that works with it, getting Incus to actually know how to configure everything. But we'll get there. That's definitely like it looks like in the future it's going to be one of the kind of main three 64-bit architectures effectively alongside x86 and ARM. All right, so this got launched, and I suspect it probably failed immediately. It did. Hey, look at that. So show log frigate. And it shows, yeah, exactly what we expected. So S6 overlay SU exec can only be run as bid one. So this is S6 init. We've got a list of paths that we expect is used by S6 to try and have it handled. Clearly, this is using a different path. I think from the forum post, it's using /init, and that's not a path that we currently allow. So let me just go look up the other ones we have. Just add /init in there and see if that fixes it. There's a very good chance it does. So let's do this. And this is not ideal, but it's because as far as I can tell, the metadata, so the runtime spec we're being provided, as opposed to the image spec, doesn't really give us too much information about what the user wants. It gives us the command and the arguments, but doesn't tell us whether this is meant to be run as an interactive command or whether it's a background command that should be its own in its system or what. So we're kind of making assumptions to make this work. And let's see. In this case, the assumption is simply that some specific paths are commonly used by init systems. If we see them, we assume now that this process is going to be capable of handling its own cleanup. So like dealing with zombie processes, doing all of the sub-reaping, all that kind of stuff. Okay, let's try starting this thing again with the console attached. Hey, that looks better. So it started and stopped pretty much immediately. That's fine. It's because it couldn't find its config file. So that's another thing that some people who have been asking about, like, hey, how do I handle shared storage? How do I handle shared storage and ports, effectively being the two big ones? Because yeah, in Docker land, you just do it with a few extra arguments and you're done. But with Incus it works a bit differently. So if we look at the Docker compose file here, we can see it's got some environment variables. It's got a bunch of volumes being attached. Specifically here, the /config thing is the important part. And then media frigate would be where the storage actually happens. And then some extra cache of a specific size that can be added. And then for devices, that's where you pass through the USB Corel stick if you've got one. That's where you pass through like some cameras if you feel like it, or you can pass the GPU to do the encoding. So obviously things look a bit different on our side. And also they run everything with maximum privileges, whereas we don't. So that's going to be a bit different. Now, ECGM size, I'm pretty sure we just respect our memory limits, so that's fine. One thing I did notice with Frigate in my own use is that the Python version in the OS they're using, I'm not sure if they use Alpine or Ubuntu or what, I think it's Alpine. It has a tendency to try and just eat as much memory as it possibly can. Which is a bit of an issue. And if you just put a memory limit, it's just going to hit that limit and then kill the container. So that's not good. The sysinfo intercept works well in my experience. So let me just start and mess with that config a bit. So we're going to create a new TMP frigate and then do a config path and a media path on the host system. And then try and make that work. So on the config side, as I said, it's got a bit of a tendency to eat up all the resources it's been given. So let's do 4 CPUs and 4 gigs of RAM. And then do security syscall intercept sysinfo true. So we intercept that system call and emulate it. I think syscall is and then on the devices front, so we want config, we want media. Config is a disk, the source path of which is tmp frigate config. And this should be mounted to, I think, /config. And then same thing here. And we want this shifted. Okay, disk, and then that's TMP frigate media. And what did they mount that again? Slash media slash frigate. Okay, cool. And was someone that shifted? Alright, was there anything else? I think it's HM, it probably does it kind of out of the box. Cache is fine, local time, don't care, it's okay. We could pass through a GPU for fun. So in our case, it's just gonna be type GPU, that should do the right thing. Yeah, that should be alright. We don't have a restart policy yet, so what does shift mean? Okay, so the container is gonna run unprivileged. So that instance is gonna run probably as like 100,200 or something like that for the UID. If we don't do shift and we pass in the host storage, the host is gonna be owned in this case by my own user ID. And so if it shows up, it would show up as the overflow ID in the container, which would show up as nobody no group. It's fine if you just need to read from it. If you need to write, then shift makes it easier by you not having to figure out what the UID translation is and doing the right chon and all that kind of stuff. So it effectively uses the Linux kernel VFS ID map feature that was added a little while back to have the kernel do the translation for you instead. Okay. Invade device name. Huh, what? This is a new one. I've never seen that error before. Okay, well, let's be a bit more specific on the GPU I want. I'm not sure why it's seeing kind of multiple or something. That's bizarre. Anyway, ID 0. Let's see if that helps. Actually, maybe I'm missing a GPU type. Anyways, GPU type is physical, and GPU ID is 0. Let's see if that helps. No. Okay, no idea what's going on with the GPU. I'm gonna have to figure it out. Like it's complaining about like CFS. Oh, I've got an idea. This guy. Yeah. Let's see if that helps. I've got an experimental like CFS thing going on. Nope. I think I know what that path means, but I just don't know why it's being annoyed by it now. Probably annoyed by this path there. Yeah, okay, no idea why. I'm gonna have to figure that one out later because that doesn't look right. This one is like it's still complaining about no config because even though the storage is being passed to it, the config file itself does not exist. So let's write a config file. I don't actually remember what it looked like these days. So let's go look at one. I'm going to my currently running one. So this is actually a Docker host, right? It's a Incus container, then running Docker inside of it. So it's got config, config YAML. There we go. Let's see what we can do. Actually, that's a bad example. I should look at the data center one because this one has all of the accelerators, but the data center one does not. So that's gonna be closer to what I can run locally. Okay. Sure. I mean, all of that is internal stuff. I don't think MQTT is even needed. Cameras are probably not needed either. Does it even need anything in the config? I'm actually wondering now. Is it YAML or yeah, it is. Okay. Not everyone agrees on the correct extension. So let's just say we enable recording, and all the recordings should be kept around for 14 days. Is it intentional to be my camera config? I mean, it would be if it was exposed to the internet. It's not, so it's fine. Yeah, all my cameras sit on a completely isolated VLAN, not routed to the internet in or out at all. And effectively, the frigate server talks to an internal restreamer that's connected to the right VLAN, and that restreamer is has a network ACL on it, so that the only thing that can connect to it are the two frigate servers. So yeah, there's no issue around that. Same thing for MQTT, it's all firewalled off. Now let's see. Okay, so it did go further, still crashing, because of required fields apparently, but did go a bit further. Your config file is not valid, please check the docs. Okay, fine. What does it need? Okay, MQTT is required. Apparently record extra fields not permitted, sure. Cameras is required. Okay. So it's requiring a bunch of stuff. Let's see. So we said MQTT and cameras, and it's complaining about extra stuff in record. Fine. What if I can just do enable false in this one? MQTT, and what is cameras? Okay, but can I just give it an empty thing? No. MQTT enable. Okay, so there's no enable for that. What extra fields not? Okay, I'm gonna have to go look at the documentation, I think. So config file. Okay, so supposedly this is a valid config they're giving in their docs, so let's see. If I put that in, I mean, obviously it's a fake config, but yep, that did something. Good. So that worked fine. Now, like the reason why I'm not even using my role config there is because of, as I said, like those firewall rules would even prevent my own desktop from accessing the camera stream, so that wouldn't really help. Cool. So this is running now, and I don't remember what port it actually runs on. It's probably 8080 or something. It's usual. Let's see if it says API 1984. Okay, so not something standard. Anyway, let's go and see if we get something on there. 1984 is it? Oh, so it's just a restreamer API. Okay, so that's not the main frigate API. Is it 8080? No. Is it 5000? Yes. Okay, so it's a standard kind of Python default port thing. And yeah, it's up and running. I mean, obviously it doesn't get any actual feeds, but the system is working fine. Can see its config, can see its logs. Storage is available. It's trying to figure out how much bandwidth it has. It can't because so it actually gets you the pub camera estimated bandwidth usage, but yeah, that would need some data to actually come in from the camera. So that worked just fine, which means the actual fix was literally just adding it to the list here. Just this one thing. So that's easy. So instance LC and such init to, let's say init paths. Okay. Cool. So that would take care of that. The question is like, what do I do next? Like we're almost an hour in, so I don't think I'm gonna tackle anything else, which makes this live stream a bit light as far as actual work. But hopefully the context was useful. Was it excluded on purpose? No, it wasn't. It's just I had to make a guess. We knew about /s6 in it, but yeah, /s6 in it came from a bug report, so I put it in. /sbin init I put in because that's the standard path. /init is not really a thing. But I mean, any path can be used as the init system. And sure, why not? Like if someone has an entry path that's called /init, it seems reasonable to assume that it's going to behave as an init system and will be able to do the process management tasks expected of it. So that seems fine. As a mention of IPv6 data addresses. Yeah, like we've got when that thing is running, it's gonna get an IPv6 address here. So I mean, in theory, I don't think I firewalled those. So yeah, if someone is on IPv6 and wants to heat up that pointlessly configured frigate server, then they could do so. Those containers usually don't stick around long enough for now. Yeah, it's related. So there's a question around like the entry point in the Docker file. So yeah, there's an entry point and they've got two different syntaxes. They've got entry point and command, I think. And they don't always result in the same thing. So if it that takes that from the Docker file, then it turns it into an image. The image manifest. So there's like three manifests. There's the manifest that goes to the registry, which is what we see with like image info, which doesn't tell us too much other than what layers are in there. Then there is an image manifest, which gives you more idea of like all of the properties of the image and how to like what's going to be expected to run it. That's where it would tell you more clearly whether it's meant to be a command or an entry point. But then the thing we actually do get on our side is the runtime manifest / specification. And in that, all we get told is this is the command, those are the arguments. It doesn't actually tell us whether whether this is meant to be an interactive command that someone is running, or whether this is meant to be like a long running background task with a proper init system. Like for example, if you run the hello world is definitely not running under an init system. So it also doesn't spawn sub-processes, so it would be fine running as PID1, but it's a bit weird because it doesn't do any of the initialization for like a thread group and all of that kind of stuff. Like all of the terminal initialization, it's not gonna do it. So that's an example where we want it to run under our own tiny init system to just handle that stuff for it properly. But then for anything else that's more complex, that runs in the background, they will often have some kind of init system, whether it's S6, whether it's what else are they using these days? Like I'm sure some people are probably using systemd, which is a bit weird for application container, but why not? And in those environments, those init systems do all of that initialization, and they actually expect to be PID1 to be able to receive any events, like specifically the child reaping events and all of the zombie management, all that kind of stuff. So those get very annoyed if they're not PID1, and that's what we've seen here. So yeah, we might eventually be able to make that more automagic. Like I did look at having our image converter pass the full manifest, so the full image manifest, which would get us more details, more information about the workload and what it can expect. But then we would need to include that in the image that we send to the actual runtime, so that as when it comes time to configure LXC to spawn and run the container, then we can do the right thing. That's actually one thing that there's some confusion about, because it's been kind of talked about with, now Incus can run Docker. That's not what happens, right? We are consuming OCI images, which also can encompasses Docker images from the registry, but we don't have Docker on the system at all, or Podman or anything like that. And those images are still being run by LXC exactly as all of our containers are. So what we can see here, it's still running under the LXC monitor. And in this case, we're gonna see that it runs S6. So in this case, that's the init system that then runs everything else. So this is PID1 for that container. If we launch, I don't know, maybe Nginx doesn't do that. I don't remember. So let's go Nginx. So if we do this, let's see what that looks like. Yeah, so that one did not have an actual init system. The main process is here. It's Nginx master process with its own subprocesses, but it only manages its own subprocesses. It's not really able to manage anything else. So say we were to, let's try to actually cause a bit of a mess. So if we go in there and then do, I don't know, sleep 60, background that, and close it. Okay, let's see what happens. Yeah, so in this case, what happened is that sleep, its parent, which was my temporary bash, got killed, and so it got reparented to the init system, which we can see here. That works because that init system understands that. It understands that it's gonna get the occasional process reparenting, and when that process exits, which should be about now, hopefully, well, 60 seconds, gonna take a while longer. When that process exits, it's just gonna completely disappear and we'll be fine. Again, waiting for it to actually do it. Yeah, I should have used something shorter than 60 seconds, shouldn't I? Come on. I really thought it was. It must have been a minute by now. Okay, there we go. Now it's gone. So that works fine. And I would bet the same is true of S6. But if I did not have that intermediate init process here, then the sleep would have gotten reparented to that. And Nginx is probably not used to inheriting random processes like sleep, and it will monitor and handle the lifecycle of its own subprocesses. But when it suddenly gets a random process showing up, that process exiting, that process triggering a sick child, it might not react to that event, which then causes the process to remain as a zombie. So if you see like processes in Z state, so that's the zombie state, that's what it means. It means their parent got the signal that the process died and did not react to it, and therefore the process is stuck in that state indefinitely. So that's how we can try and fix things with having a proper init system always be there to handle those tasks. It might not be a big issue with Docker because I don't know how often people actually go and enter their containers and mess about. But that's definitely something that we make very easy with Incus exec. So I want to make sure that we don't end up having issues because of that. And so making sure we do have a proper init process if there's no existing one in the container. Yeah, so there's a question around like the image format and what we do, like kinda. So yeah, we use Umochi to effectively convert the stack of layers coming from the store into a single root file system tree, which is then basically the same format we normally use for system containers. The only main difference that our specification for system container images specifies that there needs to be an init system, and this is gonna run as like a full distro. Whereas here it's not the case. Here we effectively have the same structure with a full root file system and our metadata in the Incus format, but we also have the extra JSON file. That's the OCI specific config, and then when we feed that to LXC is when it detects like, oh, actually there's an OCI config here, I need to take extra actions, and it goes through a different code path. So that's effectively how this is handled. So the images are, yeah, they're designed to be run by LXC. It's very similar to the OCI template that the LXC project itself has. So there's, if you use not Incus but straight up LXC, there's an LXC OCI, which does much of the same thing. It effectively also uses Scopio to get the image info, does the copy, and then it does use Umochi to do the unpack. So that works much of the same way, and then it also parses the JSON and effectively creates a temporary config for it. So yeah, internally we effectively flatten everything into something we can just run straight out of the gate, instead of keeping track of all of the layers and all of that complexity for now. Again, like it's for someone who's doing like a lot of things like machine learning or the like, they're not gonna like our implementation very much because those images have a tendency to be several gigs large, with 99% of their content being effectively shared between multiple images. So on those machines, they're gonna end up with a massive amount of data duplication, which is a problem for those kind of images. But for anyone else, like anyone who just needs to run MySQL, WordPress, I don't know, Frigate, something else like that, it's not a problem really, because you don't have that much shared in the first place. So having that flattened is not a problem. That actually reminds me, I did want to just try and start the keycloak image. I don't remember what it actually is now. So if I go look at one of my keycloak servers. Yeah, so there's a question around like whether Incus can support layer FS over LFS. So not currently. So that's the part that, yeah, we don't currently do it. We will probably do it eventually. So that's the part where we'll then end up tracking every single layer individually. But that becomes then tricky for what do you do for image replication within a cluster, because we need to have those layers also replicated, but ideally on the same machine, so that you don't need to keep having to download them from the others. And then what do you do to actually assemble the root FS? Like the way it's normally done with Docker is pretty straightforward. You've got all the layers on the disk, and then you have overlay FS stacking them in the right order, and you end up with a working tree where the actual overlay, so so all of the underlays are the layers, and the overlay data, so the actual changes, is written to the storage for the instance. And because those underlays can never change, you can just reapply things, restack things, and you're good. We can do that in most cases. There are some limitations because of the storage options we have. Specifically, you cannot use overlay FS with ZFS. So if your storage is going to be ZFS, we're going to have to flatten things because there's no way for us to do that. So that's a bit of an issue there. There's probably going to be some other restrictions, like I don't remember what the state of ID mapped commands on top of overlay FS are. If that's not fully supported, then we won't be able to make use of it either. So there are going to be some limitations, and we're going to have to support multiple code paths, and it's going to get a bit more complex and a bit more tricky, which is why I'm currently trying to avoid the whole problem by focusing on the smaller images and the things a lot of people are running, because we can have a very easy win on those, and then look at the more complex things kind of later. Anyway, just wanted to try that keycloak thing. It's on another registry. I think all the registries today. Sure. So hopefully that works too. Oops, if I write that correctly. Yeah. Image info. Let's see if it can. Oh, it's got a version thing. That's not great. Can we do latest? Yeah, okay, that's better. I'm not sure I'm not doing that on the Docker side already. Maybe there was some bug. Okay, so let's just launch it as it is and see what happens. No idea. I don't remember what the size was. What's the size? 224 megs. Okay, it's not too bad. That should be pretty quick to convert. Okay. And starting up. Okay. So there's an entry point issue here, clearly. Probably because normally it's run with a different command, I think. Yeah, it's normally run with start as an argument. We don't do arguments, so that one's gonna need a bit of a tweak. I think we might need an extra config key to be able to pass effectively an argument to the entry point command to like effectively overrule the entry point. It's probably possible to do it right now if I do keycloak. So effectively doing ra.lxc, lxc execute command, and I don't actually know what the current entry point is. Okay. Gonna have to go and peek at the file system, I think, to figure that one out. So if I look at my ZFS list, key cloak, oops, that. So if I mount this guy here, and then look at the config, no, what's it called again? There, args. Okay, so that's the entry point here. Not sure why it's not selecting it correctly, but sure. Okay. God's sake, why isn't it? No idea why the copy paste didn't work, so that's kind of annoying. Anyway, opt key cloak in kc.sh, and then start and mount this guy, set that, and then start it. Let's see if that works. Yeah, that works. Okay, so yeah, like you can override the entry point that way. It's not ideal. It would be probably better if there was a way to pass extra arguments. Like in this case, it complains because there's no config. That's fine. I didn't set any of the environment variables and all the stuff that's needed. It's just that like, this is one of those that's meant to take an argument. It's not really possible for us to do it right now. So either we need to add the ability to do that, or we need to tell people to use raw.lxc. Raw.lxc is really not something I want to encourage people to do. So we're going to be adding most likely an OCI something config option to handle this particular use case. All right, I think I'm gonna leave it there. It's been a bit of an hour. So hopefully that showed you some useful things. So we got Frigate working, that's great. Keycloak, I can get it working with that override, but most likely gonna want to do a small change to make it easier so people don't need to use raw.lxc, because we really don't like people using that. And just, yeah, kind of unblocking things as I go. Like I haven't actually moved a lot of my stuff myself because I need, and I've got an issue open for that. I kind of want an extra feature. Oh, there's a bunch of questions I need to deal with. Okay. We've got an issue here for, where is it? Subdirectories, there we go. So for Frigate, you saw that I was sharing paths with the host directly, that's fine, but my production environment is a cluster. I don't want my cluster to ever use any local path. I want everything to be coming from Incus volumes. So that's what that thing is for. Like we could currently create a volume for the config, a volume for the data, a volume for everything, and then pass those separately. Not ideal because you're gonna end up with a lot of volumes and it becomes a bit annoying. What I would rather do is have one volume either for all of my OCI containers or one per OCI container that then inside it has one folder for the data, one folder for the config, etc., and then allow us to use that. So you use effectively a subdirectory of a custom volume for a specific disk within an OCI instance. So that's what I'm trying to track with this issue. Once I get that, then I'll start actively converting all of my current Docker containers over to OCI. Without that, I would need to create, I don't know, 50 plus different volumes, and that'd be a bit crazy. So I'm gonna try and keep things simpler by implementing that feature first. Anyway, thanks a lot everyone for watching and for the chat and comments. Hopefully that was interesting. Learn some stuff about how Incus works and how the whole OCI thing works right now. And I'll see you in the next one. I'm gonna be doing another live stream next week. Pretty sure it's not gonna be on OCI, and there's also gonna be when is the next release due? So 3.4 is gonna be, I think it's first week of August, which so probably second week of August, I think. So not next week, week after. So next week is just a live stream. Week after is gonna be a release video. Again, thanks a lot for watching. If there's any question for anyone watching this after the fact, just feel free to leave them down in the comment section below and I'll answer there. Thanks. Bye.